So Brad and I will speak a bit about who we are, what we've been doing. Brad will speak about how we found Nautilus and what we've been doing together on the project. So it'll be an introduction to NautilusTrader, a reasonably high-level view. And then moving through to the use cases for the platform, a bit of a user guide, some of the different ways that the platform can be used, the current state of the project, areas which we are still working on, a little bit about the roadmap for the platform. I'll run through some live trading on Binance futures and FTX, just to show you how similar it is between the backtest environment and the live trading environment. Brad will then take us through a walkthrough of a pairs trading strategy. And Brad's actually very well placed to speak about the platform from a user's perspective. He's been doing a lot of work. I've tended to focus on low-level implementation of the platform of late, particularly when it comes to Rust, which I'll get to, whereas Brad is actually using it in a professional context. So it'll be good to get his insights there. And then we'll speak about some future developments for the project. So first of all, myself, so my trading journey really began over 10 years ago. And I quickly realized that taking an algorithmic automated approach to trading really made sense. I'm not a very good discretionary trader. So I already had an interest in programming at that point, but by necessity, I had to learn more about programming, computing. And this naturally led me to decide that the platforms that I was using at the time, such as MetaTrader 4, CTrader, NinjaTrader, they really didn't meet all of the requirements that I had in terms of risk management, access to certain order types, to certain exchanges. They really felt like charting products or charting software with order management really bolted on to the side as an afterthought, not really very configurable, not really very performant, particularly in the case of MetaTrader, running some back tests through that. I remember it being very painful, very slow. So I decided to take the long road and write my own trading platform, and that started over 7 years ago now. So originally, because of NinjaTrader was using C# as the implementation language. I'd been learning a lot of C# because of that. And so I decided to start coding a trading platform from scratch in C#. And that went on for a number of years. The first integration was FXCM and FX Broker. I actually used a fixed connection for that as well, using QuickFix. And through that process, I came in contact with some traders, and they were starting up a new FX trading firm based in Singapore, focusing on machine learning driven strategies. So they were actually very quantitative, and they were using Python. They weren't interested in programming in C# or learning any C#. So that's really where that really informed the direction towards Python. And we'll get to a little bit more about that. There's a slide coming up about the history. And I am currently working as a software engineer for a market data vendor at the moment. So I'll hand over to Brad.
Cool, thanks, Chris. I'll just keep this pretty short and sweet. Will I share my screen? Maybe, yeah, you can just throw those up, Chris. Thanks.
Sure.
So just a bit of a background on me. So I'm an equity options trader or researcher by profession. So I've worked for two big Dutch options market making firms. I spend my day writing Python for research and automation of trading strategies. And I also have a bit of an interest in sports betting. So I've dabbled with tennis and basketball modeling and automated, quote unquote trading in the past with very mild success. And so I had sort of built a system somewhat similar to Nautilus, but in a much more raw format over over a couple of years. And so about a year ago, I sort of came across Nautilus and did a bit of a deep dive. And basically, everything that I sort of saw as I was doing my deep dive was like, wow, okay, this is, sort of everything that I want out of what I would call a complete trading system, and executed very, very well. So I think diving into individual modules in Nautilus, I was just extremely impressed with the maturity of the modules and sort of basically how it did what I wanted my code to do, but in a much more correct and performant way. So yeah, at that point, I basically decided to drop what was then 3 or 4 years worth of work and contribute directly to Nautilus. So it was probably about a 3-month port of all of my code across to Nautilus. But that was a really good experience because it got me deep in the code and to have a real appreciation for the work that Chris has done. So I've worked on a few things in the past year. I wrote a Betfair adapter. So Nautilus obviously was built as an FX trading originally built as an FX trading system and then pivoted to traditional finance and crypto. But I quite easily sort of bent it to my will to enable it to do sports betting, which really speaks to the flexibility of the platform. More recently, I added an interactive brokers integration. I've done some data persistence and have just sort of helped Chris with a bunch of opinions that I'm sure he would happily just stop hearing about, things that people would sort of want in a production trading system, something they're gonna bet their money on and sort of have running potentially completely autonomously without their intervention.
Brad has definitely kept me very busy with feature requests, but it's pushed the platform in a really good direction. We sorted out a lot of little kinks, little things that have really added to the usability. And this really speaks to the whole nature of open source software. I think the project wouldn't be where it is today without all the contributions from everyone who's involved with open source through the GitHub repo, whether it be just starting a discussion to ask a question or opening an issue, bug reports, feature requests, and we've even had some awesome code contributions. So that really opened up a whole new world for me when I open sourced it. I think I'll talk about that in a moment. So, okay, history and progression of NautilusTrader. So going back to when I was first writing this trading platform from scratch, I was learning all about complex systems, design. So I did want a robust foundation for the platform. And I'd learnt about domain-driven design. So Eric Evans first wrote about that. And it's a way of being able to express a domain model through the code, defining value objects like prices, quantities, and then larger entities that aggregate events such as orders. And it really allows you to write some very expressive code, extendable code that matches very well with messaging. So I learned a lot about the actor model, Vaughan Vernon, actor-driven messaging patterns, I think the book was, really influenced me. Because I actually hit a bit of a roadblock with callback hell. And the actor model really helped me overcome that, passing messages between these simple synchronously processing actors really unblocked me at that point. The platform, as it is now, NautilusTrader, doesn't use the actor model formally. The actor model is a full specification that includes self-healing and that sort of thing. So it doesn't use the actor model, but we do have components called actors, which we'll get to later on, which are really just user-defined components that allow you to extend the platform. So I wanted something that was more performant, as I mentioned earlier, than existing platforms. And the traders who I was working with at the time, I was building it out more and more. By necessity, I had to develop a thin Python client because they didn't want to use C#. So the system by that point was distributed. So there was a data service, an execution service, a risk service, communicating across a network using a very efficient messaging protocol that I came up with Message Pack. And what happened was more and more features started getting built into the Python client, started getting richer and richer, to the point where after a couple of years, it could really stand on its own as a complete trading platform in Python. And I also got into Python because I did notice a drop in performance. I wasn't going to write a complete event-driven engine in pure Python. I knew even then that with it being a dynamic language, those loops are not going to be very fast. So I learnt a lot about Python. It was hard to get up and running with at the time, but it did help maintain the performance of the platform as more and more of it was being ported over to Python. Something worth mentioning is that through that work with the FX firm, it does have a deep history in FX. So a lot of the terminology is informed by FX. That you'll see base currency, quote currency, settlement currency, a lot of fix related terminology. And I think it has helped give the platform a professional feel, as pretty much the whole time for most of its life it has been used by professional traders. And it's been open source for over 2 years now. So I met Brad early last year, and he was at the time doing some sports betting. So when he contacted me and told me this, I was quite amazed because I couldn't believe that NautilusTrader could actually run in a betting market, sports betting. But of course, it's a market with orders, and it was doing this. So that collaboration has really pushed the platform in an awesome direction, and it's reached a level of maturity where we're excited to present it more, start opening up the channels to get the message out that we would really like people to start using the platform and hope it provides some value for people's trading. It's worth mentioning there is a large sort of sub-project with the project moving towards Rust as the core language and away from Python. Briefly, the reason for this is that Python is not a first-class programming language. It's a hybrid of Python with optional C typing. So it doesn't have first-class IDE support, debugger support, and that sort of thing. So it does make it harder to develop in the language, and it's not as correct as Rust. So Rust has been around for a while now, but it is quite a different language. It's extremely strict. I'll speak about it a little bit more, but that's where we're progressing to, is a Rust core. But it's worth mentioning that there will always be a Python API available to use the platform through, because you just can't beat Python right now for many things, including anything to do with data analysis or machine learning. So what is NautilusTrader and why? So the headline from the GitHub repo: NautilusTrader is an open source, high performance, production grade algorithmic trading platform. So the key points here: open source. It's available for anyone to pull from GitHub and just start running on their machine. We have some documentation that's starting to get fairly reasonably built out. It still does need some work. High performance coming from this Rust and Python core, with C extension modules provided through Python, allowing the Python bindings and the Python API. Production grade. So correctness is really one of the highest values of the project. I speak about it a little bit later, but when it comes to trading, so much of it is risk management, and there's already so much risk inherently involved in trading, with market risk, volatility, all sorts of things can happen. And there's also operational risk. So the infrastructure you're running on the platform, your own implementation of your strategy, there's all these operational risks. So really part of what NautilusTrader is part of the value proposition, and what we want to help traders with is alleviate some of that operational risk to make trading easier and safer. Algorithmic trading in the last few years has really become a lot more known and a lot more popular. And there's traders out there trying their hand at algorithmic trading, and they're using all sorts of things. They're writing their own code. Sometimes it's JavaScript, some pure Python scripts. There's a lot of Python available. One that comes to mind is BitMEX will give you an example robo type trader, but there's not a lot of risk management and safety measures built in. So this is one thing that we've really spent a lot of time on with this platform, all the way from the type safety that you get from Rust and Python and the domain model through to things like the risk engine and being able to specify certain risk controls. So moving on a little bit more here, providing quantitative traders with the ability to backtest portfolios of automated trading strategies. So it is an event-driven backtester. But not only that, you can also deploy those same strategies live with no code changes. So you can have a pure Python strategy written in a .py file, and you can use that same module, both backtest and live, which is a big advantage. One of the pain points for a lot of trading firms is the fact that research might happen in Python. Definitely there's machine learning involved. You can't really beat Python for that. There are alternatives, but it's very popular. But then having to re-implement the strategy in C++, C#, Java, there's a lot of developer time involved there. There's a risk that it might not be exactly the same. The quant dev might do something a little bit differently, and there's a loss of parity. So this is something that we want the platform to help solve, is being able to use that same strategy code. So the major benefits of the platform: highly performant, event-driven Python. So native binary core components, they're produced through the compilation step of the build when Rust and Python compile to native binaries. The parity between backtesting and live trading, identical strategy code. Reduced operational risk, I mentioned that before. So there's this risk management functionality through the risk engine, and I'll show you where the risk engine is in the system. There's a diagram coming up in a moment. Logical correctness. So part of the workflow is being able to backtest with the same strategy code that you're going to run live. And in doing that, you're testing a lot of code paths that you're about to deploy with real capital. So that's an advantage. And the type safety I've mentioned, highly extendable. So there are features of this system which lend itself to modularity, extendability. One of these is the message bus, and I'll dive in a little bit more on the message bus with the diagram coming up. Custom components and actors I mentioned before. So basically we don't want users and traders to have to wait for the core contributors and maintainers to write features into the platform. We've added a lot of extension points and a lot of hooks where people can implement through an interface their own components, because there's so many different ways to trade. One thing worth mentioning about NautilusTrader is we do try to remain as unopinionated as possible about how to trade and how to set up your systems to a certain point. So it's quite generic. There's not a huge amount of built-in order management. There's more a suite of methods and functionality available for you to then set up the trading how you need and for your own use case. This extends through to custom data as well. It's not just all quote ticks, trade ticks, and order book data. You can add any data to the platform as long as that data is a class which implements the data class and just adds a couple of Unix nanosecond timestamps. that can then become part of this huge monotonic stream of data being fed into the engine, and it will pass through the system like all the built-in types. Custom adapters. So for live trading, there are currently a number of adapters. There's some crypto exchanges, Betfair sports betting exchange, and interactive brokers. However, as I mentioned before, users don't need to wait for us to write more adapters. We've added these base classes like data client and execution client. And when they are implemented, you can effectively plug those into the core platform and it will run if the implementation is right, of course. But we provide some documentation to help with that. And on that, Brad and I are very good at answering questions. We like to help people out with using the platform. It is quite a large system now. It's nearly 200,000 lines of code. That compiles to over 2 million lines of C code when the C is generated. There's a lot of boilerplate in there, but it's giving you some idea of how big this system is. At the same time, we do like to keep things as simple and as clear as possible, but people invariably have questions and need some help. So we like to provide that help where we can. And mentioning once more, open source, NautilusTrader is fully open source. Everything that's currently open source will stay open source. And I think that's a big advantage for the project, so people can feel safe contributing and porting their trading to the platform. They know it's not just going to disappear overnight.
Just real quick, Chris,
Yep.
just back on the flexibility point. I'll just sort of really reiterate that.
Sure.
I think that no matter what sort of automated trading that you're doing, and I'm going to use super cast a wide net there. I think you could get data into. We think you could get your data into Nautilus and sort of write any sort of components that you think you might need that would interact with the rest of the system in an automated way. So if anyone has any questions like, oh, I've got this obscure source of data that I want to feed in, or like, I need some obscure component that I would want to interact with the rest of the system in some sort of automated way, yeah, please jump in the chat and ask, because I feel quite confident that any sort of thing that you might want to do, it would be already possible within Nautilus, in a fairly straightforward way, not without sort of hacking the system completely. It's a big selling point, I think.
Yeah, we've designed it for that use case for extendability. So, of course, any sort of raw source code you can hack to some degree, but we've specifically designed some interfaces to make it easier to do all these things that Brad was just talking about. So, on the
sorry, Chris, just really quickly, we'll just maybe just speed through these guys a little bit.
Yeah, I've spoken a lot about the performance already.
Yeah, nice.
We know why event-driven backtesting is slower. We know about the Python and Rust. Engine handles greater than 100,000 events per second. I've seen more than that as well. It depends on the compute load of the methods that are being called on your strategy or actor. The message bus itself, I've seen close to 1 million messages per second on a single thread just passing through the message bus. So there is a lot of performance there. Trivially parallelizable via configuration objects. We'll speak more about configuration objects later with the code examples. Backtest live parity. So this is probably easier to explain with the diagram, but part of the reason that there is so much parity between backtest and live is that there's this core to the platform that is literally exactly the same. The only difference between backtest and live is really where the data is coming from and where your trading commands, where your orders are being sent to. So in the case of backtesting, it's obviously all this historical data that you load up from disk or somewhere else. And that's being, your orders are being passed to a simulated venue. And this venue does simulate all of the time in force options available for orders. I think there's a slide coming up on the advanced features. In the case of live trading, it's obviously going to go through these live adapters, both data and execution clients, to the real thing, essentially. So it's formalized in the actual code with a common Nautilus kernel object. So this object takes the message bus and the cache, and it uses these to instantiate all of the engines inside itself. I'll use the slide to describe this a little bit more, and all those core components. So this allows the same strategy code developed for research and backtesting can be used to run live trading. We've spoken about that. Flexibility. So it is possible to run multiple strategies and multiple venues and instruments, both backtesting and live. So that's a limitation of some platforms, but not this one. And this works with custom external data as well, both backtesting and live. So you can predefine these data types, and it doesn't really matter where the data came from when it's instantiated. It will flow through the system in the same way as the built-in types. So I'm going to use the diagram to explain a little bit more. Okay, so a little bit more on the live adapters. We're flexible in the protocol that you can use, REST, WebSocket, or Fix API. We have used all of those actually to write adapters. And it's capable of handling various asset classes, including but not limited to FX, equities, futures, options, CFDs. Basically anything that you can represent with the domain model of the platform, which is pretty much anything. And if you can't, then it's very easy to extend. You can, for instance, inherit from the instrument base class and just write the instrument that doesn't currently exist, and it will start working for you in the platform for both backtesting and live.
Just on that, Chris, just as a really to, again, nail these points home, I don't think anything would stop you from firing up a Nautilus instance and trading a betting market against an FX market, right? You could have an execution client. If you were so inclined to trade some strategy that involved both betting and some foreign currency, you could do that. If there was an Aussie dollar future on Betfair, you could trade that against your FX broker easily, basically, in Nautilus. So just to really,
this is totally. Sorry, Brad. That's a big advantage of the IB adapter. IB just gives you access to so many traditional asset classes and markets. It really opens up the space of possibility of how you can set up trading, any kind of stat art, hedging, market making, that sort of thing becomes available. Open source. Worth reiterating that you can run this platform on-prem. There's no extra licensing fees because it is open source. So there is a premium cloud product that we're working on in the background. So some of the things that will be provided, it will be scaling backtesting. So you don't necessarily have to set up your own infrastructure on AWS or Azure. All the machinery to do that on demand will be offered by this cloud through your account, and you'll have a way to be able to visualize and monitor this occurring and being able to control that. And this extends through to live trading as well. So being able to spin up trader instances on cloud infrastructure on demand. And you will have the ability, so there'll be a few different models or a few different plans from fully managed hybrid cloud or on-prem, depending on how sensitive you are as to where your IP is. So you can host your own trading servers and traders, keep all your strategy code on your own systems and machines. Or if that really doesn't matter so much to you, you can allow the cloud to manage that as well. So it's flexible. Architecture. Okay. So something I haven't mentioned yet is the Sandbox environment. So we've established that backtesting is on historical data to a simulated venue. Live trading is obviously live data to a live venue. Sandbox environment is a bit of a hybrid. So this could use live data to a simulated venue. If you don't necessarily have access to, say, a paper trading account like IB gives you, but you did want to test your system on live data, that's what the Sandbox environment is for. And again, it uses all the same core components. Ports and adapters architecture, it's just a technique for putting together these complex systems. It allows these extendable interfaces. You can write your own implementations behind these interfaces and plug things together like Lego, and it makes the whole thing easier to develop and extend. I saw a question in the chat actually about why the move away from C#. I think C# is a great language. The move was really by necessity, just because all the quants were more interested in using Python. They didn't want to use C# to write strategies. And while C# is much more performant inherently than Python, with it being compiled, a lot of that was alleviated with Python. So there was really there wasn't a need to stay with the C# ecosystem for performance reasons. And once there was more and more Python developed and the platform could stand on its own in Python, it became actually quite difficult to maintain the API between the C# services and Python. So it was an expense. Every time there was a change on the Python side, we'd have to make a similar change on the C# side. So for that reason, it was more just the development cost. It fell away because of that. Something I haven't mentioned is the DevOps behind the project. We've spent a lot of time putting together a very good testing pipeline, a suite of automated unit tests, integration tests, and acceptance tests. This has allowed us to move quite quickly with developing the platform. It's reduced there has been times where we've had to debug. Python does make that a little more difficult. You can't just run a normal debugger and step through the Python part of the code. But there's a lot of linters, a lot of checks that help maintain a clean code base, which helps everyone read and understand the code and develop quicker. So for this next part, talking about loose coupling and components interacting. So we've had a lot of slides with text, but we've got a diagram here, and you might recognize this one from the README. So if you draw a line around everything except these data clients top left and execution clients top right, that's essentially the core of the platform, which is exactly the same code, and everything plugs into that. And sitting right in the middle is this message bus. And so all these main components are all communicating with each other via the message bus. And the message bus is capable of handling various messaging patterns from publish, subscribe, request, response, and point to point. So for instance, a strategy can subscribe to quote ticks for a particular instrument, and it will do that by subscribing to the data engine. Essentially, it sends a command via the message bus to request that from the data client, and it will flow back through the message bus to anything subscribed to that instrument for the quote ticks. If you say wanted to backfill historical bars, hydrated strategy that's just started up, that would be request response. So same thing, it's like a data command is sent to the data engine, and that will flow back through to whoever requested it. And point to point, an example of that would be, again, a trading strategy sending an order. So it would be a submit order command, and that would flow through the message bus to the execution engine. So in all those examples, this strategy did not hold a direct reference to any of those engines. It was all via the message bus. So this keeps things very loosely coupled and makes the system, once that message bus went in, the system was much easier to develop. Everything from even writing tests, you didn't have to bring up as much of the system to test it. Another core component is the cache, and this is shared between a lot of the components, and it makes getting at data and orders, positions very, very easy. So that's passed through in the Nautilus kernel. The message bus and cache are passed through most components. So that they do hold references to those, but then it keeps everything else loosely coupled.
Might be, sorry, Chris, to just interrupt here. It might be worth just kind of going over at a high level, or I'll just, if you don't mind me interrupting for a second. The way that Nautilus is architected is very similar of a lot of sort of professional trading firms, in that there's these two sort of distinct paths between data and execution. So often you will want to either just be listening to data from a venue, either recording data or just listening to it for some reason, and you may or may not want to be executing against that venue. So there is normally that's why you see these sort of these two distinct paths, data on the left and execution on the right, sort of feeding into the middle of the system. And yeah, that's
essentially data in and commands out, and then events come back in based on those. I've seen designs before that look essentially like this. I did a lot of research, and this thing's been through about 10 different design iterations to arrive at where it is now. And we will actually update this diagram because I think we can probably do a better job of it as well. Okay, language choices. I've spoken a bit about this already, actually. Just the fact that Python, you can't beat it right now, in my opinion, for anything to do with data analysis, visualization, machine learning, Rust and Python for performance. So Python in the mix here is only really to interface the Python and the Rust. It is a goal for the project that one day you'll be able to run live trading with a system that's entirely Rust, but that's a longer term goal that we're working towards. As mentioned before, there'll always be a Python API, and Python will probably always be utilized with backtesting. So we have been seeing some gradual and continuous improvements as more and more core components are ported to Rust, which is quite exciting to see, and it's making the platform better and better and safer. So Brad's going to talk a bit more about Nautilus as a complete trading system.